Hi everyone and welcome back to NTE. Okay, so one of your colleagues is asking, how do you factorize a cubic function, right, in order to get your x-intercepts, right? So remember that the process of factorizing a cubic function is an intermediate step that is required when you are asked to sketch the cubic function, because obviously you're going to need to indicate your x-intercepts, okay? So I thought that maybe let's start with the theorems that are involved, right? And let me write the theorems the way that they're most probably written in your textbook, okay? So maybe the way that I'm stating the theorems is what's confusing you because you don't see the connection. So if you use, I think it's classroom mathematics, okay? The theorem of the factor and remainder theorem might be stated like this. I do stand to be corrected, okay? But this is one version of stating the factor and remainder theorem, okay? So basically, the factor and remainder theorem is two separate theorems, okay? There's the remainder theorem and there's the factor theorem, okay? Right, so the remainder theorem is simply just a statement, okay? It just says that if you take a polynomial, right, and you divide it by another polynomial, ax minus b, right, then the remainder is simply going to be given by f of a over b, okay, where this b and this a value comes from that polynomial that you divided with. Let's look at an example very quickly, right? So if you take the polynomial for example, k of x, right, equals to, right, let's use a quadratic polynomial because that's quite an easy polynomial to work with. K of x, right, is equals to x squared minus 5x plus 6, right? And we say that we divide this polynomial, okay, by another polynomial, x minus 3, okay? Remember that the remainder theorem talked about dividing by this polynomial ax minus b, right? So ax minus b, right? If you compare that with your polynomial x minus 3, okay, then you can see that your a value, okay, is equals to 1, right? That's the coefficient in front of the x, right? And then you have this minus sign, which is corresponding over there. That's fine. So which means that your b is equals to 3. Okay, so b is equals to 3. Okay. Another way that you could have come to that is just to set the polynomial that you're dividing with equal to 0, right? So x minus 3 equal to 0, x is equals to 3, right? So which means that you need to be substituting an x value of 3 into your function. Okay, that's another way to get to the answer. Okay, but anyway, let's stick with this, right? What the remainder theorem is saying is that, okay, your remainder, which we can just indicate with a capital letter R, okay, so the remainder of this process of dividing x squared minus 5x plus 6 by x minus 3 is going to be equals to f of b, in this case is 3, divided by a, which is 1, which is going to be equals to the f of 3. Okay, so now remember what the f of 3 is saying. The f of 3 says that go to your function, right, and wherever you see an x, you're going to substitute a value of 3. Okay, so this is going to be 3 squared minus 5 times 3 plus 6. Okay, so 3 squared is 9, and negative 5 times 3 is going to be a negative 15. Okay, and we still need to add on 6, right? But 9 plus 6 is 15, so that's just going to be 0. Okay, so then comes in the factor theorem. right? So the factor theorem then says if this f of a over b, right, gives a result of 0, right, like what we just saw right now. So in other words, if the remainder equals 0, okay, this is the remainder, okay. So if the remainder equals 0, right, then that original, okay, polynomial that you divided by is a factor of your function f of x. Okay, so in our case, what we saw is that the remainder is equals to 0. So then, therefore, you can then conclude that this polynomial that we divided by, x minus 3, okay, x minus 3 is a factor of k of x. Okay, so the student's question is, how do we factorize 3x cubed minus 2x squared minus 13x minus 8 to get the x-intercepts, right? Well, the simple answer to this question is that you're going to use the factor theorem. Okay, and remember that the factor theorem is the one that said that if the remainder, okay, is equals to 0, then ax minus b, right, the polynomial that you divided by, is a factor, right, where this remainder was given by f of a over b. Okay, and you can see how the way it's written in the textbook, it's quite hard to imagine what you're doing. Okay, which is why I just simplify this factor theorem to simply just thinking about if the remainder, okay, is equals to 0, right, where your remainder is given by f of k, right, so you just collapse down this possible fraction into just an integer, right, so k an element of integers, right, then you are able to conclude very quickly that x minus k, right, so the opposite sign of what's inside the bracket here, right, is a factor, right, and the opposite is true as well. So if the remainder is equals to 0, right, where the remainder is equals to f of minus k, right, then x plus k is a factor. Right, so in finding the x-intercepts of our cubic function, right, so this is specifically for the cubic function. You can't go any other way in order to factorize the cubic function. You have to use the factor theorem, okay? So in finding the x-intercepts, right, what the factor theorem is saying is that the first thing we need to do is to find this k value, right, and it can be a positive k value or a negative k value, right, that you need to substitute into your function, right, with the goal of finding an output of 0, okay, and once you hit that output of 0, then you can either conclude that x minus k is a factor if the number that you substituted in was a positive value, or x plus k is a factor if the number that you substituted in was a negative value. Okay. All right, so let's then look at how do we then factorize this specific cubic. Okay. Okay, so you can start by saying let f of x, right, equal, right, the polynomial that we are looking at, which is 3x cubed minus 2x squared minus 13x minus 8. Okay, and then you can say for x-intercepts, right, so for x-intercepts, let f of x, which is y, equals 0. Okay, so then therefore 0 is equals to 3x cubed minus 2x squared minus 13x minus 8. Okay, so then you would then go into the factor theorem in order to find your first factor. Okay, so let's grab a calculator. So we are now going to substitute into our formula different values of k, right? And to make life simple for ourselves, we're not going to think about substituting in b over a, which is the possibility of substituting in a fraction, right? We are just going to think about it in a simpler way of just substituting a k value, which is an element of integers. Okay, so we're going to think about substituting in 1 or negative 1, 0, 2 or negative 2, 3 or negative 3, and so on. Okay, so let's try substituting in 2. Okay, okay, we see that substituting in 2 does not give us an output of 0. Okay, so basically what's happening here is that the f of 2 is equals to minus 18. Okay, so which means that this is not a remainder of 0, so then therefore x minus 2 is not a factor, right, of f of x. Okay, so let's try the negative version of 2. Okay, so minus 2, minus 2, minus 2, and we get an output of negative 14. Okay, so f of minus 2 is equals to negative 14, right? And because this is not 0, then you can say that x plus 2 is not a factor as well. Not a factor of f of x. Okay? Let's move up a section and let's try 3. Okay, and we see again we don't get 0. Okay, maybe let's move down and just try 1. Okay, again we don't get 0. Let's try negative 1. Okay, and there you go. You now get an output of 0, right? And that's what you're looking for. Okay, so the f of negative 1 is what gave us an output of 0. Okay, so then therefore we can state that our first factor is x plus 1, right, is a factor of f of x. Okay, let's just make some room over here. Okay, so this over here is what we were looking for. The k value that gives us a remainder of 0. Right, so once you've found this first factor, okay, your step 1 of factorizing f of x is done. Okay, you are now going to have to find your other two factors, which are going to come from something called a quadratic factor. Okay, and in order to get those other two factors, you're either going to need to use polynomial long division, synthetic division, or inspection. Okay, in this video, let's use polynomial long division. You would draw yourself a division sign like usual. Okay, so what you're going to put on the side over here is the polynomial that you're going to be dividing by, which is going to be this first factor that you just found. Okay, so that's going to be x plus 1. Okay, and then inside of the division sign, you're going to put in your original function. Okay, so 3x cubed minus 2x squared minus 13x minus 8, right? And then how this works is that when you divide with polynomial long division, you divide using your x term, okay? And then once you've done with the division, okay, when you get to the multiplication step, right, whatever is going to be at the top over here needs to multiply both the x term and the constant term. Okay, so let's see how that works. Okay, so we're going to start with this first term of 3x cubed, right? So 3x cubed, and we're going to divide it by x, right? When you divide, okay, let's write it out. So 3x cubed divided by x. Okay, so when you divide 3x cubed by x, what you get is 3x squared. Okay, this answer goes to the top over here. Okay, so we're going to have 3x squared at the top over here, right? Then that answer you need to then multiply with both the terms of your first factor. Okay, so that's going to be 3x squared times x is going to be 3x cubed, and then positive times a positive is a positive, okay, and then 3x squared times 1 is just 3x squared. Okay, once you're done with that, you need to put this into brackets, and what you're going to do now is you're going to subtract this result from your original function. Okay, so you're going to draw a line. Okay, so 3x cubed minus 3x cubed is a 0, and we put a dot like that. Okay, and then negative 2x squared minus positive 3x squared. This negative would multiply with this positive to be a negative. Okay, so this is basically just negative 2x squared minus 3x squared, which is going to be a minus 5x squared. Okay, now that you're done with that, you need to bring your next term down so that you can carry on, right? So this is then minus 13x. Okay, and now we need to start the process all over again. Okay, again we're going to take this x, right, and we're going to divide it into this first term. Okay, so what we're going to have is minus 5x squared divided by x, right? That's going to be equals to minus 5x. Okay, this answer, okay, then needs to go up the top over here. Okay, so we'll then have minus 5x at the top over here, and then that answer needs to then multiply, remember, both the terms of your first factor. Okay, so when we do that, we're going to have negative 5x times x is going to be a negative 5x squared. Okay, negative 5x times a positive 1 is going to be a negative 5x. Okay, you then need to put that into brackets, and now you need to subtract. Okay, draw yourself a line. Okay, so now let's do the subtraction. Okay, negative 5x squared minus negative 5x squared is just negative 5x squared plus 5x squared. Okay, that's going to be a 0, so we put a dot. Okay, negative 13x minus 5x is negative 13x plus 5x. Okay, so that's going to be a negative 8x. Okay, and then you bring your last term down, which is this constant of 8. Okay, sorry, of minus 8. You bring that down. Okay, after you're done with this step of bringing down, you then need to start all over again. Okay, so by start all over again, we mean that this x needs to divide into this first term again, right? So when we do that, we're going to have minus 8x divided by x. Okay, that's going to be equals to minus 8. Okay, this answer then needs to be written at the top over here. Okay, so when we do that, we're going to have a we're going to have a minus 8 over here. Okay, and this minus 8 must then multiply both the terms of your first factor. Okay, so minus 8 times x is minus 8x, right? And minus 8 times a positive 1 is going to be a minus 8. Okay, you put this into brackets and you subtract. Draw yourself a line. So then negative 8x minus negative 8x is negative 8x plus 8x, which is going to be 0. Okay, so we put a dot. For the constant terms, you'll have negative 8 minus negative 8, okay, which is just negative 8 plus 8. Okay, again, that is 0. Okay, and this 0 over here is important because this 0 then tells you that this whole expression of 3x squared minus 5x minus 8, this is your quadratic factor. Okay, so the factor theorem allowed you, okay, to get your first linear factor, okay, and we concluded that that was a factor because the remainder was equals to 0, okay. Again, with the same logic over here, when the remainder is equals to 0, it's very important that the remainder over here is 0. If you don't get a 0 in this last step, you need to go back and check your computation. You probably did a mistake somewhere along the line. Okay, when you get this output of 0 over here, then what you've written at the top over here is your quadratic factor. Okay, so your first factor, okay, together with your quadratic factor, is what's going to help you to factorize your original polynomial even further. Okay, so remember what we had is that 0 is equals to 3x cubed minus 2x squared minus 13x minus 8, right? So this is your function in expanded form. Now we're going to write it in factorized form. Okay, so 0 is equals to the first factor, x plus 1, times the quadratic factor, which is 3x squared minus 5x minus 8. Okay, but this is not completely factorized because we all know that we can factorize a quadratic polynomial even further. So all of these, right, this, and this, okay, these three brackets, right, are the factors of f of x. Okay, notice also, even though we are not going to be sketching this function, but it's important to know these things, right? Notice that you have a repeated factor over here of x plus 1, okay, so which means that if you were to sketch this polynomial, okay, your graph would have to be tangential to the x-axis at that x value of negative 1. Okay, right, but then anyway, in order to carry on now and actually find the x-intercepts, now you're ready to find the x-intercepts, right? You would then set all these three factors equals to 0. Okay, so we would have x plus 1. We can combine that to be x plus 1 squared, right, equal to 0, or 3x minus 8 equal to 0. Okay, so solving this first one, we'll take the square root of both sides. Okay, so leaving us with x plus 1 is equals to 0. Okay, so then the first x-intercept is at x is equals to minus 1. And the second x-intercept is going to be at 3x is equals to 8. X is equals to 8 over 3. But you would have to remember that this specific x-intercept of x is equals to -1 is due to a repeated factor. So this is an x-intercept and a stationary point. Okay. Remember that the shape of our cubic function is determined by the coefficient on x cubed, right? And in this case, the coefficient on x cubed is greater than 0. In other words, it's positive. So which means that our polynomial or our cubic needs to start from the left hand side. Okay, so this is the left hand side. It needs to start from the left hand side, and it needs to go up first and then down. Okay, so positive means you go up first, right? Now, this x value of -1 is not going to be a simple x-intercept where you're going to intercept the x-axis like that, because it's also acting as a stationary point, right? Your graph has to bounce at that point. In other words, it has to be tangential to the x-axis here at -1. So it's going to look something like this. Okay, so this is then f of x, right? So basically, to answer this question, how do we factorize 3x cubed minus 2x squared minus 13x minus 8 to get the x-intercepts? Well, you factorize it using the factor theorem to get your first factor, and then you use polynomial long division, or you can use synthetic division, or you can use inspection, right, to get your quadratic factor, right? And then your quadratic factor needs to be factorized even further, right? And then once you have those three factors, you set each of them equals to 0, and those values of x are going to be your x-intercepts, right? For this specific example, it just happened that you got a repeated factor, so I reminded you guys that when you get this repeated factor, it means that that x value is acting as both an x-intercept and a stationary point. So your graph needs to, now when you take it further and think about graphing this f of x, possible f of x, okay, then it needs to increase, right, touch at that x is equals to 1, come back down, right? This specific one would have a y-intercept at -8, okay? It would have a minimum point somewhere. Okay, you would get this x value at the minimum point by setting f prime of x equals to 0, right? And then it needs to go back up again and cut at that x value of 8/3. Okay, right, so that's it for today's video, matriculants. I hope you learned something, and I will see you guys next time.